Okay, so is there anything you can tell me about chemical reactions? What is anything and everything you know? Left, I heard left side.
Left side reacts.
It does. And when you say left side, sorry?
Hey, who took my sheet yesterday?
I don't know.
Taylor was using it.
Okay, I was just talking about that earlier. Okay, I've got a copy here. So anything that we've missed so far, you can go back to the Science Channel if you choose. Okay, now with that being said, okay, if you are having problems with this, what can you do? You can ask questions. Okay, and it's your responsibility to do that or take accountability for that. All right? Also, okay, thank you. So, you said everything you knew. You mentioned the left side reacts. That's true. But left side of what? A little more specific. Equation. How's that? So if that's what's on the left-hand side, or the arrow, what's on the right-hand side?
No, it's the little number, whatever it's
What's on the right-hand side?
the product.
The products are on the right-hand side. Okay? So, as we continue, all right. Okay. Okay, this is another part of our exercise that you will be responsible for, and that is dealing with what we call decomposition reactions. We're telling you what it is, then you move forward from there. Okay, so it's unfortunate we got to spend time to do that, to say, is everyone's phone up there? Okay, so what is the formula for calcium chloride? Okay. Okay, what is symbol for the chloride ion? Okay. When we got to balance out the compound or molecule, we always say go by which charge? Go by the negative charge. Okay. So, which one of these has a negative charge to it? Okay. Which is what? Negative. Okay? Notice it doesn't say this up here, does it? If there was a Roman numeral up there, what would that be for? That's telling you the charge. That's right. Okay? So, but why don't we have to have that for calcium? Because it's in column 2. It only has one charge. You wouldn't have that for zinc either, even though that's a D block element. So what's the charge of calcium? Okay, what's the least common multiple between 1 and 2? Okay, so how do we get these charges to add up to 0? Okay, so what this is saying is this will decompose to this. Running out. Okay. So as this decomposes into its separate parts, we've got what is calcium plus what? What do you mean by 2? How about that? Okay, now in front of each one of these compounds or elements or molecules, okay, do we have to put the 1s in there? Okay, because it's just understood there's a 1 in front of each one of these. Okay, so then go ahead and put your elements below here. Calcium's left. Calcium's right. Chlorine's left. Chlorine's right.
Wait, why don't we add that 2 right away?
What are we, 2 right away what?
For calcium. That's a charge. Yeah, that's supposed to be charged. You don't do anything for that.
Okay,
Oh, my bad.
what are we talking about here?
Nothing.
Okay. Do we need to change anything here?
No.
No, it's balanced. So to the right, sometimes these equations are already balanced. Okay? So what do we see? What happens in a decomposition reaction? A compound is going to do what? It separates. We had, see how this breaks apart into its associated components. Calcium on one side, chloride on the other. All right. We don't have a whole lot to go over, but nonetheless. Okay, this is where we left off with yesterday, correct? So then the example that we just went over is also a decomposition reaction, just like what this is, okay? I think, so mercury 2 oxide or mercury 2, okay, breaks apart into mercury and oxygen, okay? That's a decomposition reaction, okay? So when we balance these, we come up and use coefficients. And it's just trial and error, okay? There's 1s in front of all these compounds, and then to balance them out, you may put a 2 in front if you choose to or need to. And as you can see, regardless of any chemical reaction, new products are going to be formed. It doesn't matter any type of reaction you're referring to, whether it's synthesis. Some of you had already alluded to photosynthesis. Okay? To you, what does that mean, photosynthesis?
When a plant takes in sunlight and gives itself some food.
Well, it doesn't give itself some food, it's actually making it, and that's, in short, that's exactly what's happening. As the sun is shining, okay, the leaves, which are green because it's got chloroplasts and chlorophyll in it, absorbs the light, and then what's given off as a byproduct? Yeah, oxygen's given off. So the carbon dioxide in the air, the water from the soil, and then the sunlight being absorbed will break those water molecules apart, and that's why oxygen is given off as a byproduct. Okay? Okay, we're going to do just this. I can just a moment. Okay? Because as we apply these concepts, when you see this happening in the reactions, it'll hopefully make it easier for you to understand. That is the goal. because one of the aspects that we will do is a type of exercise like this over in the lab where you're reacting two things together. And when you do that, okay, when we say precipitation, what does that mean to you? Can be. Rain is one. Well, any type, yeah, anything that falls out of the clouds. The idea is falling out of the clouds, whether it is rain, snow, sleet, unfortunately, hail. Okay, what happens in this chemical reaction, okay, when you react these two components in a liquid, a precipitate falls out of the solution. That's what we mean by that. That is what falls out, just like that within the clouds. A type of moisture that falls out of the clouds. A precipitate. Precipitation. Okay, then let's see here. This will be the last slide that we do today. It will illustrate what we had just seen on the previous slide. And I've always thought it was unique, maybe, or neat when some of you individuals, perhaps in 2 years, okay, you young men and women in 2 years, perhaps take general chemistry. One of the exercises we do with this is not only this chemical reaction, what a limiting reactant is, what a product is being formed, how much is being formed, and how much should be formed. Okay? Now that's a lot to take in. I get that. We'll illustrate. We'll do something very similar to that, but we do it together as a group. You're not doing it on your own like you would be if you were a junior taking the class. Okay? Okay. Does everyone have this? Okay? Got it? Okay, so I just need to look at that again. Nickel 2 chloride, sodium hydroxide. Okay, got it. So notice that we're using a lot of the information that you had learned last chapter. Okay? So with this, okay, so nickel 2 chloride. And then it said plus sodium hydroxide. Eventually, you'll be responsible for doing this on your own. So that's why we want to practice this together as a group. Okay, symbol for nickel. Okay, Cl. Okay. Do we need to change anything to this compound? Okay? Now, does everyone understand why that 2 has to be there? Right, because this is -1, that's +2. We don't know what charge nickel has because it'll also be a +3. So this is telling you that this has a +2 charge. Okay, what is sodium hydroxide? Sodium is hydroxide. Okay. 1 hydroxide ion has a charge of negative what? Okay. Sodium is an alkali metal, so it's got a charge of what? Do those add up to 0? Yes, they do. These do not, but once we put that 2 there, it does. So, in this double replacement reaction, okay, Can two positive ions bond to one another? No, it has to be a positive and a negative charge. So the positive ion of this component bonds to the negative ion of this component, but on this side. So let's go ahead and write that down. So nickel's got a +2 charge. Out of here, what's got the negative charge?
Hydroxide.
OH, or hydroxide. Okay? Then the positive ion of this compound bonds with the negative ion over here, but on that side. Sodium and... Do we need to change anything on that side?
Yeah.
Yes, we do. Okay?
I am just
Okay, the charges do not change. Sodium chloride, do we need to change that? No, because that adds up to 0. Does this add up to 0?
No.
Okay? So the least common multiple between 1 and 2.
2.
Okay?
What are you going to use this for in our life?
Teaching you a good work ethic. How's that?
See how I'm going to use this on the toilet for reading.
Well, whatever floats your boat. Okay? So, -1 and +2. What's the least common multiple?
2.
Okay?
-2, actually.
Okay? It's not a value, it's just a charge. Okay?
Then you would write that up there.
Okay? Now, is that compound written correctly now?
Yes.
So now we can go ahead and balance this.
What happens if you have like 5 different like compounds? Then how do you know what works and what way?
We would not be doing anything that complex in here. Okay? Okay, one of the things that happens is, for those of you who take general chemistry in 2 years, there's a complex reaction that we talk about with the Apollo space mission program, where you're taking 3 different components to make rocket fuel that you would want to make sure that's in the right proportions. Your brother could tell you all about that if you choose to have that conversation. Okay, so proceeding forward, the next best thing that you can do, some of you can probably do this in your head, some of you have it balanced already. Was that a correct presumption? Okay, so otherwise, if you feel you need help with this, give me some elements that we would write below the arrow. Nickel, chloride.
Hydroxide.
Okay, now, to me, the best way to look at this is you have hydroxide on both sides. Keep that together. Okay? That doesn't always work, but that's probably the best way to deal with balancing these. Okay, so nickel's left.
You need sodium.
Okay? Nickel's right.
1.
Chloride's left.
2.
Chloride's right.
1.
Okay, hydroxide's left.
1.
Hydroxide's right.
1.
Sodium's left.
1.
Sodium's right. Okay? Where would you presume is the best place to start?
With your chloride.
Okay? Because these are at a 2-to-1 ratio. We've got 2 chlorines on the left and only 1 on the right. By trial and error, we've got a 1 in front of each one of these. Okay? Okay, these are all 1s right now. Okay? So you had said you want to start here because we have a 2-to-1 ratio. So how do we get 2 chlorides over here? Okay, so once we do that, distribute that through the entire compound. How many sodium? Yes, how many sodiums do we have now?
2.
Okay. Distribute it through the entire compound. How many chlorides do we have? 2. We now have 2. Okay. So our chlorines are balanced, but our sodiums are not.
Put a 2.
See, I put a 2 in front of the sodium.
Okay, so if we put a 2 here, distribute that through the entire compound. That makes this a 2. What does it do to your hydroxide then? Okay? So in our blanks over there, 1, 1, 1, 1 is not quite correct.
1, 2, 1, 2.
Okay? So this is still a 1. That's now a 2. This is a 1. That's now a 2. Okay? So that would be what you'd want to write in there. 12, 12. Sure.
1,212.
Yeah, don't want to do that.
Okay?
112.
Left outside and left middle. We're okay. Left middle. Left middle. Okay? Middle. Right side. All right. Again, we're more than happy to help you should you have questions, but you have to take. Agreed? All right. Okay.
2 minutes in?
We'll catch up to you next time.